So in the previous lecture, we discussed at length about conditional statements. So in today's lecture, we'll be talking about the truth table for conditional statements. So if we have two statements, P and Q, then a conditional statement will be if P, then Q, or simply if P implies Q. Right. Now, since there are two statements, so there will be four possibilities. That meaning we can have either two truth values. It could be either false or it could be a true statement. And to raise to the power of, we have two statements, so that will be 2 squared, which will give us four possibilities. The possibilities meaning either both P and Q are true. The second case, when P is true, Q is false. Third case, P is false, but Q is true. And in the fourth case, both P and Q are false. So that means they are going to have a truth value for each of the possibilities. So let's talk about each of them one by one. For this, we are going to consider a particular example that will help us arrive at the conclusion. Let us consider this particular condition. We have the first statement P, which is winning a basketball match, and statement Q is going for a pizza treat. Now we consider the first condition when both P and Q are true. So the conditional statement P implies Q, that would simply mean if you win a basketball match, then you go for a pizza treat. Well, let me make it in this way. If your team wins the basketball match, then your team goes for a pizza treat. Now, let's consider this particular statement. So, if your team wins the basketball match, then your team goes for a pizza. So that means this is a true statement, the team winning the basketball match and going for a pizza treat, that is also a true statement. So in this case, when both P and Q are true, so that means if P is true, which implies the Q, statement Q is also true, then the truth value will be, it is a true statement. Let's go to the next case. Both of them are false. If P is false and Q is also false. So what does P implies Q will give us? It's very easy to think. So if the P being a false statement means, P will simply means your team didn't win the match, and Q, your team didn't get the treat. So makes sense. So if we consider P implies Q, so if then statement will become, if your team didn't win the match, then your team didn't get the pizza treat. Now this, if we look at this particular statement, this makes complete sense. Like if you didn't win the match, then you didn't get the treat. So we will consider this to be a true statement. So that means when you have P false, if it implies that Q is also a false statement, then this will have a truth value of true. Okay, let's go to the third case. Let's say if P is true and Q is false, then what will be the truth value of the conditional statement P implies Q? That means T implies false. Let's think about it. If we write it in the compound statement form, this will be, if you won the basketball match, then your team didn't get the pizza treat. So here, if we look at this carefully, now these logically think about it, this does not seem appropriate because you won the basketball match and then you're denied of your treat. So what we'll consider, this is a false statement. So that means when we have the compound statement, T implies false with a true value which implies a false value, then this means the statement is false. And let's go to the final scenario. So we have P is false, then Q is true. Let's say what will be the truth value of this particular conditional statement. So we can write the compound statement as, if your team, since it is false, your team didn't win the basketball match, then your team goes for a pizza treat. So if we think about it, nothing was mentioned about what if you didn't win the match. The only condition, it's like if you win the match, then you go for a pizza treat. Here nothing was mentioned about what if you didn't win the match and you still went for a pizza treat. So this is fine. So here in this case, when the statement P is false, and if it implies that we are getting a true value, then this is going to be considered as a true truth value. So that means now if we rewrite all of the 4 scenarios in the form of a truth table, then we will have, so when P and Q are both true, then if P is true, then Q is true, is going to give us a true truth value. If P is true, then Q is false, so this is going to give us a false truth value. If P is false, then Q is true, so this is going to give us a true truth value. And finally, if P is false, then Q is also false, then this is also going to give us a truth value true. Now let us work on few problems that will help us understand the truth values and truth table for a conditional statement. So let's look at our first example. Determine the truth value of each of the following statements. So we have 4 different statements here, and we have to figure out the truth value of each of them. So let's begin by considering 2 statements, P and Q. So let's say P is the statement, Paris is in France. And Q is the statement, 2 plus 2 equals 4. If we negate the statement P, not P, so that will be Paris is not in France. Or we can also consider that Paris is in Canada. And similarly, the negation of the statement Q will be 2 plus 2 equals to 5, because this is not a true statement. Right. Now, let's consider the first one. If Paris is in Canada, then 2 plus 2 equals to false. Paris is in Canada means not P. If not P, then Q. So we have a false statement going towards a true statement. So this has a truth value of T. Second statement, if Paris is in France, so which is a true statement P, then we have 2 plus 2 equals to 4, which is a true statement Q. So from true going towards true, so that gives us a true statement T. Number 3, if Paris is in France, so this is a true statement P, then 2 plus 2 equals to 5. So we have not Q. And we know that P going to not Q, so this is going to give us a truth value of false, because if the antecedent is true but the consequence is false, then we get a truth statement of false for a conditional statement. And finally, we have Paris is in Canada, which is not P. Then 2 plus 2 is not equals to 4, or 2 plus 2 equals to 5, which is the negation of Q. So in this case, we are going to get the truth value of T, which is true. Let's go to the next problem. So here we have 2 statements. So let's begin one by one. So we'll consider the statement P as 2 plus 2 equals to 4. Then we have the second statement Q, which states that 3 plus 3 equals to 5. And we consider the third statement denoted by R. It says that 1 plus 1 equals to 2. Now if we write statement 1 in symbolical form, so that will be if P, this implies 3 plus 3 equals to 5, which is the statement Q. We have a conjunction with the statement R. Now, let's consider P to be true. 2 plus 2 equals to 4, so that's a true statement. And we have Q, 3 plus 3 equals to 5, so this is a false statement. And R, 1 plus 1 equals to 2, this is a true statement. Now we know that the conjunction of false and a true statement is always a false statement. So here we are getting here. So we started with a true value, but we are getting a false value. If true, then false. Just remember the previous example, your team won the basketball match, then you didn't go for the pizza tray. So this is the case where we're going to get a false truth value. So this is going to be false. Coming to the second one. So we have 2 plus 2 equals to 4. So this is P. Then we have 3 plus 3 equals to 5, which is the statement Q. Now OR means we have a disjunction. And then we have 1 plus 1 equals to 2, which is the statement R. So P is a true statement, Q is a false statement, or R is a true statement. Now, since we have a disjunction F or T, so this is going to be true because at least one of them has to be true. And we know that when we have a conditional statement of if true, then this is always going to yield a true truth value. Let's go to the next problem. Example number 3. So here we have 3 statements, P, Q, and R. So it's given that P is true, statement Q is false, and our statement R is true. So using these 3 truth values of P, Q, and R, we have to check the truth values of each of the following statements. So let's start with statement number 1. So here we have the conjunction P and Q. So if P and Q, then R. We'll use the truth values now. If true and false, then true. True and false. So we have a conjunction here. So the conjunction between true and false values will give us a false. So if false, then true. And we know that for this conditional statement, the truth value is always going to be true. Let's move on to the second problem. Problem number 2, we have disjunction if P or Q, then R. So that means we have true or false, then true. Now since this is a conjunction, true or false, this is always going to be a true statement because one of them has to be at least true for a disjunction to be true. If true, then true. So this means this is a true statement. Number 3. So we have if P or, and we have a conditional statement here, if Q, then R. So this will be, so P is true. Let's write down all the truth values. So we have, or if false, then true. We'll work with the conditional statement within the parentheses. So we know that when it is false, if false, then true. So this is going to be a true statement. Just remember the example of the basketball match. If your team didn't win the basketball match, then the team went for a pizza trip. That was a true case. So we have true and true. This is a conjunction. So since in the conjunction when both our statements are true, we get a true truth value. Moving on to number 4. So we have 4 if P, then R. Right. So P is true. We have true going to true. So true implies, so if true, then true, this is a true statement. And again, if true, then true, this is a true statement. Now let's come to the 5th problem. So in the 5th problem, we have if P, then Q, then R. So we have P, which is a true value, which is a false value, implies a true value. If true, then false, this clearly means that the hypothesis is not giving us a correct conclusion. So this is going to give us a false statement, false. And if false, then true. So this is going to give us a true value, C. And let's come to number 6. So 6 will be P or Q. If P or Q, then not R. So P is true or false, then not R. So now R is true, so not R will be false. Right. So true or false, this is a disjunction, so this is going to be true, then false. If it is true, then false. So this is a false statement, which is again the same case as the hypothesis is not enough condition for the conclusion to be true. So that's why when if true, then false, that would simply mean that we have a truth value of false. So we need to construct the truth table for the statement if P and Q, then P or Q. So we have 2 statements, P, Q. So let's consider all the possibilities. So both of them are true. One of them is true. and both of them are false. So we'll start with finding out the truth value for P and Q, the conjunction between P and Q. So this is going to be true only when both of them are true, rest it will be false. Then we find out the disjunction P or Q. So this is going to be true for at least one of the values of P and Q to be true, and it will be false when both of them are false. Now we come to the original statement. If P and Q, then P or Q. So that means we'll consider column number 2 and column number 3. Okay. So if true, then true. So this is a true statement. If false, then true. So this is also a true statement. If false, then true. Then true statement. If false, then it is a true statement. This is going to be the truth table for the given compound statement. And also, if we look at the final truth value, so we are getting a true value T for any combinations of P and Q. So that means here we have obtained a tautology. So in this way, we can say that this particular compound statement is a tautological statement. So in this particular example, we need to construct the truth table for the statement if P and not R, then Q or R. So that means here we have 3 statements, simple statements, P, Q and R. Since there are 3 statements, so we'll have 8 possibilities, so that will be 2 raised to the power of 3, which is equals to 8. So let's list them out. When all 3 of them are true, then we have true, true, false. So here R is false, or we could have true, false, true. Here Q is false. We have true, false, false. This times Q and R are both false, or we have false, true, true, false, true, false, 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 true, and the final case where all 3 of them are false. Okay, let's begin from left to right. So we need to take care of the negation of R. All we have to do is flip the values of the truth values for R. So we have false, true, false, true, false, true, false, true. Right. Next we take the case P and not R. So for this we need the first column and the fourth column. So this is going to be true only when both of them are true. So let's see. So this is the second case. So this is true. So we have here, this will be true. And I think rest of them will be false. That's because if one of them is false, then in a conjunction, we get a false truth value. Right? Now, we'll consider the second compound statement, Q or R. So let's consider the second and the third column. So this is going to be true when both of them are true, or at least one of them is true. So this is true, true, true. When both of them are false, it's going to be false. So there are no, so this final case also, both of them are false. So this is going to be false and rest will be true. Now we come to our final conditional statement. If P or not R, then Q or R. So that means if false, then true. So this is going to be a true statement. If true, then true. So this is a true statement. If false, then true, true. If true, then false. So this is the case where it will be false. So here we can see for all the other cases, it will be a true value. For the last as well, if false, then false. So this is also a true truth value. So this is how we can construct the truth table for the given compound statement. Example number 6. Let's prove the following conditional statement. These 2 statements are equivalent. So we start with the 2 simple statements P and Q and list out the truth values. Both of them are true. One of them is true. And both of them are false. Now we begin by considering the negation of P. All we have to do is flip the values of P. So we have false, false, true, true. We'll begin with the first conditional statement. If P, then Q. So this is going to be true. If true, then true. So this is true. If true, then false. So this is a false statement. If false, then true, this is a true statement. And if false, then false, this is a true statement. Then we have to find a disjunction between not P or Q. So for this, we'll consider the second and the third column. So this is a disjunction. This will be true only when one of them is true. So this is true, true, true. And the second scenario, we have false. So clearly we can see that these two truth values are exactly equivalent. So we can say the conditional statement if P then Q is equivalent to not P or Q. This is an extremely important equivalent statement that becomes very handy in certain scenarios, which we'll talk about a little later. So in this particular example, we will show that the two conditional statements are equivalent. So we have not P, if not P then Q. This is equivalent to P or Q. So we begin by noting down the truth values of P and Q. We also consider the negation of P, so that will be flipping the truth values of P. Next, we consider the conditional statement not P, if not P, then Q. So we'll consider column 3 and column 2. So we have false, if false, then true. So this is a true statement. If false, then false. So this is a true statement. If true, then true. This is a true statement. If true, then false. So this is a false statement. And if we consider the disjunction P or Q, so this is going to be true for if at least one of them is true, and false when both of them are false. So clearly we see that the truth table are the equivalent. So we can say if not P, then Q. This is the same as saying P or Q. So these are two equivalent statements. Final example, here we have to rewrite the following statement as a conditional statement. So we're given either you reach work on time or you are fired. So let's consider the statement P, you reach work on time. And statement Q will be you are fired. Now clearly this is a disjunction. So we can write P or Q, you reach work on time or you are fired. Now, in the previous example, we showed that the disjunction P or Q, this is equivalent to not if not P, then Q. So if we consider the negation of the statement P, so that will be you don't reach work on time. So now we'll consider not P and Q. So using this particular statement, which will be a conditional statement, we will get if you don't reach work on time, then you are fired. So this is how we can construct, or you can convert the given disjunction into a conditional statement, and both of them will mean the same thing.